Hey guys, today we're going to start Unit 13. It's thermochemistry. I handed you a blank packet before we left on Monday, so take that packet out now, and that's what we're going to work through. I'm going to try giving you notes a different way today, where I'm going to take notes with you, so hopefully I explain it as we're going along and it's not so fast as like if I just explain it with a full set of notes. Okay, so follow along. I'm gonna share my screen with you in 1 minute. This one. Okay. So I don't think you get to see me. Okay, that works. All right, so in this unit, you need to know the phases of matter. So push pause for right this minute and fill out questions 1, 2, and 3. You should know this. It's from Unit 1. We also did it in Unit 10. So try to do that. And then, yeah, unpause it, and then I'll fill in the notes with you. All right, so we have melting a solid to liquid, vaporizing, liquid to gas, freezing, liquid to solid, condensation, gas to liquid, sublimation, solid to gas, and deposition, gas to solid. Okay, in an endothermic reaction, heat is endo going in, so heat is absorbed. Exo, heat is released. So from above, they include, so for endothermic reactions, think about which ones would work if you put them on a stove or had a fire underneath them or something. So we have melting, vaporizing or boiling, and then sublimation, choice E. And then the ones that are exothermic, they need to get rid of heat in order to happen. So we've got freezing, condensation, and deposition. Okay, so I'm gonna go back and forth. There we go. And let me move this down. Okay. Annotate, clear. Okay. Start with some black. Okay, so this is a heating curve of water. This is the shape of a heating curve. Basically, you have temperature on the y-axis, time in minutes. It could also be like reaction progress. The first line you see is solid. Second line, slanty line you see is liquid. This is where these phases are warming up. And last one is gas. At the line that's straight, this is where you would find solid and liquid in equilibrium. So meaning they exist at the same time. Up here you have a liquid gas equilibrium. Okay, change colors. Okay, so at the points where you have a flat line, that's where you have all your phase changes. So in this direction, solid to liquid, you have melting. This direction, vaporize. And then in that direction, in order for that reaction to happen or that physical change to happen, you need to add heat. So this is an endothermic direction. So anytime you're going solid to liquid to gas, endothermic. Let's change colors. So we're at gas, going back. We have condensation. I'll just write condense. In this direction, freeze. And since this one starts at high temperature and needs to get colder, that means you need to get rid of heat. So in this direction, that is exothermic. Okay. So the lines on the edge, so the flat line, trace it over here. That is the melting point or the freezing point. Melting and freezing point are the exact same temperature. So I'll just write from now on MP or FP. So melting and freezing occur at 0 degrees Celsius if we're talking about water. And then up here we have the boiling point. Or BP, and that is 100 degrees Celsius. So anywhere along this flat line, it's 0 degrees. Anywhere along this flat line, it's 100 degrees. A couple more things you need to know. Kinetic energy, KE, is equal to temperature. So since kinetic energy is equal to temperature, which is the y-axis, you could get a question like, where is temperature changing, or where is kinetic energy changing? So kinetic energy changes all of the slanted lines. Okay, and then we have potential energy, and that happens on the flat lines. And this is wherever you have a phase change. Remember, triangle means change. So potential energy on the flat lines. Solids have the least potential energy. Liquid and gases have the most potential energy. Okay, so take a minute to copy that down. Okay. So during a phase change, it says the temperature remains constant. So we're talking about the flat lines while potential energy is changing. And that is because energy is being used to change the phase. So when you change the phase, you are weakening if we're heating it up, or strengthening intermolecular forces. And these are the forces in between our molecules. So let's say we are in a solid form and we're changing into liquid form. Remember, intermolecular forces are the attraction between your molecules. So as you're heating up, those forces are weakening. So this is for heating. If you're cooling down, those forces are strengthening because you're coming closer. They just threw a snowball at the window where I'm working. Okay. All right, on to page 2. They're still throwing snowballs at the window. Okay, this is a cooling curve. We're not going to draw the whole thing, but we're going to draw part of it. Okay, so cooling curve is basically the opposite. This is the shape of a cooling curve. Begins with gas. Stop it! Still throwing snowballs. Liquid, solid. This is the gas-liquid equilibrium, liquid-solid equilibrium, melting point, boiling point, and then in this direction, since you're cooling down, it's exo. In the opposite direction, it is endo. Okay, so we're gonna do some practice problems. What I would recommend doing every single time you get this is labeling the heating curve as soon as you see it. Okay, so going below here, sorry, I'm getting used to this still. You're going to use this heating curve along the side, okay? So whenever you get a heating curve, I would automatically begin by labeling solid, solid liquid, liquid, liquid gas, gas. And I would also label boiling point, freezing point, and melting point, which are the same number. Okay, so pause this video now to answer the questions, and then I will go over the answers when you unpause it. Okay, question number 1, what temperature is the freezing point? So if they're labeled, these are really easy to see. So question number 1 is 5 degrees. What temperature is the boiling point? 15. Melting point is same as freezing point. What letter represents where solid's being warmed? So ignore this part being warmed and just, where's the solid? A. Same on the next one. Liquid being warmed just means liquid's temperature is changing. C. Vapor is another word for gas. E. Okay, I'm just gonna leave this up so that we can see the diagrams. So number 7 over here. Okay, which represents the melting of a solid? B. 8. Which letter shows vaporization of a liquid? D. 9. Which letter shows potential energy changing? B and D. Flat lines. Where is kinetic energy changing? All the slanted lines. Number 11, condensation is second flat line. And crystallization is another way of saying freezing, so that is letter B. Okay, that's the answer to those. Okay, so pause the video again. And let's do page 3 together. So I'm going to clear this and scoot this down to page 3. Pause it, and then unpause it after you've completed the practice problems. Okay, so again, I would label these solid, liquid, gas. Solid, liquid, liquid, gas, boiling point, melting point, or freezing point. Okay, so we did that for number 1. What is happening in the forward reaction? So forward reaction is this direction. Okay, so at line B in the forward direction, we are melting. Forward direction for line D, vaporizing. Is the forward reaction a heating or cooling curve? It's only heating because your temperature is getting higher. At line B, what's happening in the reverse direction? So reverse is just top to bottom. Or right to left. So letter B is freezing. I'm gonna leave these up so you can see the picture. Okay, number 6, what is happening at line D in the reverse direction? It's condense. Number 7, is the reverse reaction heating or cooling? It is cooling because it is going down. Number 8, if the substance is water, what are the temperatures? So the boiling point would be 100 degrees if it's water, and the freezing point would be 0 degrees. So at line B, you've got 0 degrees. At line D, you have 100 degrees. All right, number 9. At which 2 lines is the temperature remaining the same? B and D. And then why is there no temperature change even though heat is being added to the substance? So the energy is used to weaken intermolecular forces. I did not say strengthen because strengthen is only for a cooling curve. So weaken intermolecular forces, and then it can change phase. So if you wrote phase change, that should be fine too. All right, 10. Which phases are represented at each line? Line A, solid. Line B, liquid solid. Line C, liquid. Line D, liquid gas. And line E, just gas. Okay, and then let's see. All right, so 11. Which phase of matter is represented at negative 200? So if we're at negative 200, we are right here. We are at a solid. So 11A is solid. B, if you're at 105, you're up here. So that is gas. C, which phase of matter is represented at 0 degrees? Right here, solid and liquid. And then letter D, at 100 degrees, which is your boiling point, liquid and gas. And then letter E, just liquid. Okay, so I think we'll call that a day. Tomorrow we'll do our first set of heat equations, so you'll need a calculator. I think we'll probably end up doing both. Well, I don't know. We'll see. I don't want to overwhelm you. Maybe one set of heat equations and then a homework assignment to summarize the first couple concepts. Okay, and that's it for today. Take care.